Hi, today I'm going to show you how to secure your microservices using Spring OAuth2. In this tutorial, we're going to build an authorization server and a resource server. I'll try to keep things as simple as possible, so without any further ado, let's dive into it. So the first step to build an authorization server is to go to start.spring.io to bootstrap our project. Of course, you can set it up yourself, but really, who wants to do that, right? Now, I'm going to use Maven and also Spring Boot 2. The dependencies that we're going to need are support for OAuth2, and we're going to need a database to store the user's information. But because this is just a demo, so I'm just going to use a memory database, which is H2, but you can use any databases you like MySQL or MongoDB. Also, we need the web module. And finally, we need Spring Data to do all the CRUD operations. The name of this application should be Authorization Server. Okay, hit Generate Project to download this to our local machine. And let's go to the downloads folder, unzip the file. And I want to move this project to my project folder. Okay, so let's go to the this project and open it in your favorite IDE. I'm using IntelliJ. Now, usually Maven will take a few seconds to download all the dependencies. I think we're done here. All right. So the first thing I want to do is to replace the property file with the YAML file. But this is just my preference. You can use the property file if you like. So application.yaml. And in this YAML file, I want to specify that I want the server to run on the port 8081. Now let's go to the application class and try running this to see if everything is okay. All right, so as you can see, our server has started and is running on the port 8081, so that's good. The next thing we do is to annotate this application class with @enable authorization server to tell Spring the role of this application. Now let's try running this to see if there is any difference. As you can see, beside the generated password, Spring also gives us a generated client ID and client secret. But we don't want these because we want our own customized client. Now I want to show you something here. If I use Postman to send a request to localhost 8081, it will return a 404, which is not found because we haven't defined any endpoints for this server yet. But if we send another request to localhost 8081/OAuth/token, it will return an 401, which is unauthorized. We haven't defined this endpoint yet, have we? Actually, we kind of have, because when we annotate this class with @enable authorization server, this also gives us an endpoint to retrieve the token that we're going to use later. Now we have this endpoint. Let's go and define the client's information. To override the default config of Spring OAuth2, I would need to create a configuration class. Let's call it auth server config. And this class needs to extend from authorization server configure adapter. We can annotate this with @configuration so that Spring will understand this is a config class. From the superclass, we want to override 3 configured methods. The first one is to dictate who can validate a token. What does it mean? Well, after this authorization server provides the client with a token, the client application will use this token to access other resource servers. So these resource servers will first need to take the token from the client and go ask the authorization server that is this a valid token. And they do this by using the endpoint /OAuth/check token. The problem is, by default, this endpoint is not exposed by the authorization server. So we need to open it now. So security.checkTokenAccess is authenticated. So you may be wondering what is authenticated. If you search for Spring expression-based access control, you will find that this expression means it returns true if the user is not anonymous. In this case, it means only authenticated resource servers are allowed to check if a token is valid. So that's simple. The next one is where we define the client's information. Now, by default, the Spring Boot 2 uses bcrypt as its password encoder. So if we want to define the client secret, we would need that encoder. So let's define this password encoder. Let's call the encoder, and we return the new bcrypt password encoder. I'll just write here to keep it consistent. Now we have the encoder. Let's define some information about the client. So to keep it simple, I'm just going to use in-memory client. So clients.inmemory with client. The client ID is going to be client, and the secret, we're going to use the encoder to encode the secret, which is secret. The authorized grant types here, I'm going to use password. And the scopes, just put in anything you like. I'm just going to use all. So now we have a client to play with. In the last configure method, this is where we defined the authentication manager, and also we designed how the server will gonna store the tokens. So to do this, we need 2 beans. We need the authentication manager bean and also the token store bean. So I'm just gonna go bean token store. And to keep things simple, we'll use in-memory token store. Okay, so all the word in. Okay, what about the authentication manager bean? Where can we get it? Well, I'm gonna create another configuration class, called it web security config. And this class will extend from web security configure adapter. And this should be a configuration. So web security configure adapter is an abstract class, and that is why we need to create a concrete class for that. So from the superclass, I will override a method called authentication manager that will return the object we want and mark it as a bean. So now we can override in authentication manager. Okay, now we have 2 beans. Let's configure that. Token store and also authentication manager. That's it. This is all the code you need to write for the auth server config to override the default config of the Spring OAuth2. But we are not done here because client's info is not enough. We need the user info to retrieve the access token. So let's go and configure the user's data. To have the user's data, first we need an account entity, obviously. So I'm going to say account. And I will use JPA for this because I want Hibernate that goes bundled with Spring Data will map this entity to H2 database at runtime. So this entity should have a ID and a username and a password. We're going to mark it as ID and generated value. All the constructor we need, actually we only need username and password. And non-argument constructor. And all of the getter. Whoops. Okay. The next thing we need is a repository to read and write the accounts to our database. So I'm going to use Spring Data for this. So account repository. And there should be an interface. Whoops. Repository. This repository will stand from the JPA repository. We will provide the entity name and also is ID data type. So account and the ID is integer. We only need one method for this, which is find by username. So I'm going to say optional of account find by username. And we'll provide a username for this. Whoops. Okay, that's good. Now's the important part. We need to customize the service layer so that Spring will look at our class to check if the username and the password are correct. To do this, we need to create a new class. Let's call it custom user details service. And this is a service. It must implement the user detail service. And as you can see, we have to implement this method, load user by username. In this method, we will use our account repository to go to the database and to check if the username exists. If it does, then we need to map the account to an user detail object and return it. So to do so, we need to inject the account repository that we created. And also we need the password encoder. So here I'm going to say account repository by username. And because this returns an optional, so we have some options here. So I'm just going to say if the account exists, I want to map this account to an user object. So keep in mind that this user object is provided by Spring Framework, and it implements the user details interface. So it satisfies the return type of this method. So here, account.getUsername, and the encoder.encode the password. Down here is where we decide if the account is active, if expired or locked. I'm going to put all the true here to make things simple. For the authority, I'm going to say authority utils, create the authority list. just put in write and read basics rights. So what if the account does not exist? Then it means the username does not exist. So we're gonna throw an exception. Username not found exception, and the message is username does not exist. So this is our custom user detail service. Now we need to tell Spring to use this service instead of its default service. So we're gonna go to the web security config and override another method, configured. Also, I need to override our own custom detail service in. So here we're going to say auth user detail service, custom users detail service. So from now on, Spring will use our class to check the username and the password instead of using its own default class. So we have done all the necessary configuration for our authorization server, but there's one last thing, that we don't have any accounts in our database yet. So I'm gonna go to our application class and make it implement the command line runner interface. Command line runner interface is provided by the Spring Boot framework. What it does is that every time a Spring Boot application starts, it will go and look for the command line runner concrete class and run it. So this interface has one method, which is run. So I'm gonna auto-wire the account repository. So every time this authorization server starts, I want to delete all the data in our database, and I want to add new account. So the username should be my name, and the password is 123. To prove to you that this run every time the application starts, we're gonna say it works. So let's try running this server to see if it actually works. That's good. Let's test our authorization server with Postman. So here I'm gonna send a post request to ATH1 OAuth token. For authorization, I'm going to use basic auth. The username should be the client ID, and the password should be the client secret, which is secret. For the param, we're gonna provide the username of the user, which is my name, the password, which is 123, and the grant type, underscore type, password. Let's try sending this request to the authorization server. And there we have it. We have the access token, and now we can use this access token to access all the resource servers. So we just built an authorization server, and now to create the resource server, we need to give it a client ID and client secret first. So I'm going to say and with client, and the client ID for the resource server should be resource server, and the secret is, we're just going to leave it the same as secret. The authorized grant type is password, and the scopes is all. So now I'm going to run this authorization server on the port 8081 in the background. At the meantime, let's go to the startup.spring.io to bootstrap our project. Resource server is the name. We need the web support to expose the endpoints and also the OAuth2. Okay, hit generate project. I'm going to do the same thing. Unzip the resource server and move this project to my projects folder. Open it in your favorite IDE. So as you remember, for the authorization server, we need to annotate its application class with the enable authorization server. And we need to do the same thing with the resource server. So art enable resource server. This annotation here will do a lot of auto configuration for it. Now, the next thing we need to do is to give this server some properties. So I'm gonna delete the properties file and replace it with a YAML file. But again, this is just my preference. I want this server to run on the port 8082, which is different from the authorization server. So here's the important part. I need to tell the application where the authorization server is and also its client ID and secret to communicate with the authorization server. So security OAuth2 resource, the token info URI is the authorization server. So HTTP localhost 8081 OAuth check token. For the client, we're going to use is client ID is resource server, and the secret is secret. The authorized grant type is password. Okay, so now to test this, I will create a controller. Let's call this hello controller. This is going to be a REST controller. And here we'll create two endpoints. One is public endpoint. We're just gonna return a simple string. So public hello. Hi there. So anyone can access this public endpoint. Now we need to create another endpoint, a private endpoint. And only those who are authenticated can access the endpoint. So private hello, return welcome to the dark side. Now I need to set the rules for these endpoints. So we need another class. Let's call it web security config. And this one will extend from the resource server configure adapter. We're gonna annotate this with configuration. And we want to override the configured method to set the rule. So authorize request and matcher. If they want to access the /private, they have to be authenticated. But for the public, anyone can access it. Now let's try running this. Okay, let's test it with Postman. So I'm gonna send a request to the localhost 8082/public. There. So we are able to access it. Let's try with private. Now we have the message that for authentication is required to access this resource. So in order to access the private resource, we need to get the access token from the authorization server. So I'm gonna send a post request to localhost 8081/auth/token. The params we're going to use, as you remember, username is my name. And the secret, no, actually, this is a password, is 123. The grant type is password. For the authorization section, we're going to use basic auth, and the username is client. The secret is secret, so send a request. Now we have the access token. That's good. Let's get back to the resource server and see if we can access the private endpoint. So in the authorization part, I'm gonna use the bearer token, paste it here, and try it. Welcome to the dark side. So that's very nice.